My name is Yasser Al-Mashad. I work as a security specialist for F5 Networks. In this video, we will talk about the recently discovered Kubernetes vulnerability that allow privilege escalation and unauthorized access inside the Kubernetes cluster. And then we will talk about how to mitigate this vulnerability. But first, let's explain a couple of concepts. This is an example Kubernetes cluster. In the top there is the master node, and then the bottom you see the worker nodes. There are different components running on each one of these nodes. But if you notice in the middle there is this API server component. The API server is the heart of Kubernetes cluster. All the communications, external communications or internal communications in the cluster, they go through the API server. In this case, the API server is the vulnerable component. Next, there is this concept of the namespace. A namespace in Kubernetes provides an isolation of the resources. So each namespace can have a set of pods and services and the quota and the policies and service accounts. You can think of the namespace as a virtual cluster inside the Kubernetes cluster. In a large deployments or a big organization, usually each division or tenant have its own namespace, or sometimes each environment like production or test and the dev, they have different namespaces. In this vulnerability, it allows users who have restricted access to a specific namespace to gain unauthorized access to another resources in different namespace that he does not have access to. So with that, let's get started. So Kubernetes come by default with the top 3 namespaces. I have created this test namespace for this demo. And what we will do is that we will place one pod or microservice inside the default namespace. This will be our production namespace. And we will have also another workload running inside the test namespace. Then we will have a user that have access only inside the test namespace. And then finally, we will try to exploit the vulnerability by trying to execute commands with the user identity of test namespace inside the default namespace. Okay. So I have already pods running inside the default namespace. I have one single pod that's called Nginx production. I have also another one pod that's running inside the test namespace. It's called Alpine test. And I also created the service account. This is the configuration. So I created a service account. The name is test user. And this service account will be inside the test namespace. And then I created a role that grants full access to the resources inside the test namespace. And finally, I done the role binding to apply this role to the test user. So in summary, I will have the test user that will have full access inside the namespace test, but nothing else, meaning he does not have access to any other namespaces. Okay. Now you notice that I've been executing commands using kube control. Okay, and whenever I use kube control, it means that I'm sitting inside the cluster as an admin. The kube control command reads its configuration from the kube config. This is my kube config, and you can see this is an admin user that have already a token and have a client certificates and a client key assigned to it. But later on, when we exploit this vulnerability, we will be using REST API calls to simulate access from outside the cluster. And when I execute these calls, I will need to pass my authentication token. Now, when I created the service token, when I created the service account, Kubernetes automatically created a token for this service account. And I need to have this token to use it later. I can get that by describe the service account that run inside the test namespace. The service account name is test user, and you can see here there is a token created already. So I need to have the value of this token. I can get that also by describe the secrets inside the namespace test, and the secret name is this token. So this is the value of this token. You can see this is a JOT token that have 3 values separated by dot. In fact, this is encoded in base64. I can decode it using this online tool. You can see the token is on the left, the decoded values on the right. This is the test namespace, and the username is the test user, and so on. I will need to pass this to a session variable because I'm going to use it later. So let me create session variable. Let's call it token, and we'll pass the token value to it. Okay. So now I should have it stored here. Okay, great. Now, before I execute the vulnerability, I want you to see what's executing commands looks like, and what's the output of executing command look like. Okay, so I have this pod, which will be our target in the default namespace, and the pod name is this nginx production. And now let me try to execute command in it. So I'll say execute the command in nginx pod, and let's run the command ID. Very simple Linux command that will return the user ID and the group ID, and this is it. Of course, this works because I'm doing it as the admin who have access to the all containers and the all namespaces. Okay, so now let's run the vulnerabilities. So first, let me use the curl to test our REST API call. So I'm gonna send the curl command to the Kubernetes API server, okay, and I will try to list the pods in the test namespace, and I will pass my token as a bearer token, which I stored already. Okay, now this should work because my test user have access inside the test namespace, and yes, it worked. Let me make this nicer output by passing the JQ. And if I go to the top of this output, you can see it say the pod list, and I have the pod name Alpine test in the namespace test. And the rest is basically just detailed specifications about this pod. If I try to execute the same command but trying to list the pods in default namespace, I should get the forbidden message. So it say the test user does not have an access to the default namespace. So the test user does not have even a read access. He cannot read or see or list anything in the default namespace. In fact, he cannot read or list anything in any other namespace than the test namespace. Okay. So now this is where we're going to kick the vulnerability, and we will need to first build a channel with the Kubernetes API server. I will use the netcat, and I will connect to the API server over the port 6443. Okay, and the first thing we'll do, just to verify, I will try to execute a command, which is the ID command, on the nginx production pod that's located in the default namespace, and I will pass my test user JOT token. Now this should fail because, as you know, this user does not have access to the default namespace. And yes, as you see, it's forbidden. And again, the test user does not have access to the default namespace. Okay, now I will try to execute the same command but using a different way. This is where we're going to exploit the vulnerability. First, I will try to run the exec command on the Alpine test pod, which located in the test namespace, using the test user token So this should work because the test user have an access in the test namespace and the all pods inside it. But most importantly, I will try to upgrade my connection to WebSocket. Let's execute this. And this work irrespective of this error output. Basically, it say that this is a bad request. You need at least standard input, standard output, which need to be passed to the execute command. But this is not a problem. What matter here is that I have authenticated successfully. I have an authorized session now with the Kube API. And now I will try to reuse this session to execute my next command. And this is where the vulnerability kicks in. And the next command is the same REST API that I failed to execute earlier, but now I will try to execute it again. Just quickly review, I'm trying to execute the command ID on the Nginx production pod that's in the default namespace using the same test user token, but now I'm passing it as a WebSocket key. So this command failed earlier, but now let's see if it will work now. I'll paste it here. And as you see, it was executed successfully and it returned the output here. It showed that the status is success. So what this means is that I was able to gain access and execute commands on containers that I do not have access to, that run in different namespaces that I do not have even read access to. I could even run or execute commands in any other namespace than the default. It could be the Kube system namespace itself, where Kubernetes store the cluster configurations and the sensitive data. That's why this is a critical vulnerability. So now let's talk about how to protect against it. Okay. I have here a F5 that have a one virtual server. This is the virtual server that I was been using already in my curl and in my APIs. So all what I was doing was going through the F5, but without any protections enabled. Okay, this virtual server have one single pool member, which is the actual Kubernetes API server. Now I'll go to the advanced configuration of that virtual server. And first, let me review few things about the virtual server configuration. I need to apply HTTP profile. I need to apply both SSL client and server profile. And I also need to apply WebSocket profile. So I have WebSocket profile also applied. This is pretty much what you need. Now let's apply the security. So I'm gonna apply my application security policy. And let's test the vulnerability now again. So I'll go back and I will execute the same command. Sorry. And you see this time I get the request rejected. This is actually the blocking page from F5. Let me go to the F5 and see what's going on. Let me put this full screen, increase the resolution, go to the security events logs. And we can see there is one event kicks in here. Okay, and it triggered two violations, and you can see the request here at the bottom, and the token is sanitized by default for security reason. So let's look at the violations. I have triggered two attack signatures. Okay, let's see both of them. The first one is not important. It is just a signature that triggered because I have the test word in my directory. Of course, it's not a good idea to expose a test directory to the world, but we can ignore this. The second one, what matter, this signature name is Kubernetes privilege escalation. This is exactly designed to mitigate or to catch this exploit. Okay, you can see this was created and updated shortly after this vulnerability discovered. This is the URL where the vulnerability, the exploit kicks in, and it's a WebSocket. Okay, you can see the request here, it's a WebSocket, secure WebSocket, so we can identify the normal URLs from the WebSocket URLs. Interestingly, the other violation here is related to the WebSocket itself. It's a bad handshake. It shows a few details about that it's wrong or missing a specific header, and it shows the expected value for this header. So we could mitigate this vulnerability through different ways. The first one is through the attack signature, which come out of box and it catches this easily. The other way is through the WebSocket compliance checks, which we can also configure to add additional mitigations or additional protections if we want. You can go to the URLs to allow WebSocket's URLs. We can have a different protection for each URL, but here I have one default protections for all URLs. And few protections here is there. We can enforce the payload format, so I can control if this payload should be plain or JSON or binary, and I can have a profile for the JSON and the plain text that have more security features or controls on the JSON format or on the plain text format. I can also allow or control what's meta characters allowed and what's disallowed. I can also enforce the cross-domain request on the WebSocket URLs. Okay. So with that, thank you for watching.